intake of BTEX, the benzene, toluene, that's the estimates that the average American is exposed to these. You can see, you breathe the air, you are exposed to benzene, toluene, and these are in microgram, how much you get every day. Now benzene, that's so nasty, you find it in a lot of foods. About 20 different foods, you are going to find some level of benzene and toluene. These things are everywhere, not only in the industrial production, in what we do, but also in nature. Okay, next. And then the monitoring. There is a national survey, the NH, the NANES there, NHA, NES. It's a series of surveys, and they go around and they pull blood from the people, and then they measure them. So this is supposed to be, in theory, representative of the entire population of the US. They don't, they cannot do it for people that are indoors, outdoors. It's the entire population. You can see that the 50th percentile, meaning the average of the middle of the people, benzene 0.26. 95th percentile is the highest, it's about 0.31. So that's your average levels of benzene, toluene, ethylbenzene, xylenes in Americans, and you have that. It's a report about that big from CDC and from the National Center for Health Statistics, showing that if the average American is going to have these levels, 0.26 in part per billion in their blood. Part per billion will be a microgram per liter. So we all have that. So what do you do with medical monitoring? You are going to find that a bunch of people have some levels. Where does it come from? The toluene, does it come from your fingernail? That's fairly easy. They are going to look at your fingernail, and if they are short, even if they are long, but if you don't put polish, that's okay. But if you have nail polish, that's it. Somebody is going to say it's the fingernail. You can see that medical monitoring, it's interesting to know. Now, why do they do things like that? They do things like that, and it's fairly useful. In the 80s, the 70s, and the 80s, when you start putting a measurement in the tailpipe of the car, you would have levels that were 100 times higher than they are now. You know, the level of benzene, toluene.
It's higher then than they are now?
Yeah, because they don't have catalytic converters, because they didn't have all the combustion of the engine was not so good. So the purpose of these things is to have a picture of the US, and that is, if they decide that the major source of benzene and toluene in the blood of the people come from the car exhaust and the circulation, then you have to do something about the exhaust. And so what do? You put a catalytic converter, you adjust the engine, you make some changes. In the good old days, we used to have lead in the gasoline. And that translated in a high level of leads in the children, in the adults, but also the children. Lead is never useful. So there was a lot of studies done to decide, can we do without lead in the gasoline? And so once they remove the lead in the gasoline, you have less lead in the streets, in the city. It's not gone. There's still a lot of lead. You have lead in the paint. We remove that. You have lead in the gasoline. They remove that. So studies like that are useful to see, okay, we are going to do catalytic converter. We are going to do a bunch of things to lower these volatile organic chemicals in, and then we are going to see, according to the surveys, we are going to see if these things go down. But that shows you that everybody has some level of some chemical. We live not only in a chemical society, the nature is full of these chemicals. If you look at the levels that we have in nature. And I think that's probably the last one, no? Yeah. That's the last one. You can close it.
Oh. Take what you want and go for it.
So, any questions? Eggs, tomatoes, in a box? I hope I didn't...
Have you run any studies on the sinkhole or anything like that? Have you run any numbers on the sinkhole with that norm in the tablet or something?
It was very low.
Oh, you don't know nothing.
Yeah, it was the levels that they have measured was very low. There is another issue about putting radioactive material in the sinkhole. That's not in my lane.
Okay. I was just wondering about the gas that's coming out, like the
Yeah,
noise.
there are very few levels that were done, and they are very low. They are, and you can go to the next one. No, what
Oh,
before?
sorry.
And go to the one before last.
Well, I really messed this up.
Yeah.
Okay, this one?
Yeah. So they had some things in liquid, and the way they had measured it was in picocurie per liter if something was in a liquid, or picocurie per gram. Picocurie was 2.2 disintegration per minute.
Yeah, I'm trying to do that. Thank you, sorry. Okay, Dr. Ricard, you want to know?
Yeah, you put it at custom slideshow.
Second one from the left and top left. Second from the top left.
This one?
Second from the top left.
This one?
From the current slide, yes.
Actually, if you look on the bottom of the screen, right next to 66%, it looks like a little screen
Slide it over to the right.
right there. The little, no, right next to the percentage,
Go up to the right.
Yes.
right there.
Ah, thank you.
Welcome.
Okay. So a picocurie is a measure of the number of disintegration. Pico means milli is 1 in 1,000. A millionth, 1 in 1,000, 1 in a million, 1 in a billion, and then 1 in 1,000 billion.
Yeah.
And so the pico, milli, buffering again. Yeah, but 1 millionth,
Billion.
and then you go down. Okay, so one picocurie, 2.2 disintegration per minute, and that's one of the unit of radioactivity. So you can see for the bismuth 214 and the lead 214, you had 9.46 in liquid per liter, 11.7. And in the solid, you had 0.87, 1.1, 0.26. The background radiation level in rocks vary from 0.5, the background radiation, every rock, in the order of 0.5 to 5. So it didn't look like it was very high. And then on the other side, for the aqueous phase, you have some numbers that you can easily find on the website. The salad oil is 4,900 picocurie per liter. So then you are going to say, okay, I don't eat salad anymore, I'm going to eat steaks.
Can you tell us about radium-226?
Yeah, the total of radium-226 and 228, the total in a natural rock is about 0.5 to 5. So the levels that they found there, but there was not, I didn't find too many in what I was able to look at, seems to be fairly low, much lower.
Can you tell me what does it cause for the health situation?
The very low level?
The radium.
The range, it's in nature. You have radioactivity everywhere. You can see bananas is 3 picocurie per gram. I mean, radioactivity is all over. You heard about the radon in the houses. You go to a building full of granite and the radioactivity will be much higher. So what does this low level cause? We don't know. We live with it.
Well, but isn't it a fact that it does cause cancer?
Anything can cause cancer. I mean, not anything, but...
Most everything.
Well, I guess what I'm saying is that it's nice to fluff over these things, but these things that are cancer-causing, especially if they are in norm, and since we have norm issues on that dome, it's a concern to us as to what will norm cause in our community. Will it expose us to a higher rate of cancer?
Salad oil. If you ask me, looking at that, I would say salad
oil
oil.
isn't norm, though, is it?
It's radioactivity.
Huh?
Norm is naturally occurring radioactivity material.
Does salad oil have radium-226?
Yeah, 4,900 picocurie per liter.
Of radium-226?
No, not of radium, of radioactivity.
Okay. But I was asking about radium-226.
Radium-226 would have two effects. Number one, radium can be a toxic effect like any other chemical, any radium. I suspect you would have to eat a lot. I don't know the numbers. Then you have the radioactivity. Whatever radioactivity is the same, is a disintegration. So radioactivity, you would have alpha particle, beta particle, and gamma particles. Any of the alpha particle, probably more difficult because you have to swallow them. They really don't go through the skin. Beta, and particularly gamma rays, can easily go through a lot of things. So they would be more dangerous than the alpha. So these are measures of radioactivity. Now, once you have looked at these three types of particles, whether it comes your salad oil or radium-228 or whatever, 228, is the same effect. If you have gamma radiation coming from your salad or your radium, it's the same. It's the fact that the gamma rays are going to go inside the cell, they are going to attack your DNA and cause a mutation. And that mutation may be harmless, or that mutation may be the beginning of a cancer that will develop. So the radioactivity has nothing too special, except that you have three different types. But once we have the three different types, whether it comes from the salad, the milk, the peanut, the banana, or a piece of rock, it's the same. That's what I understand.
Doctor, we understand you telling us what we don't need to worry about, the resident.
I didn't say what you don't need.
Nobody's worried about salad oil, nobody's worried about milk and drinking whiskey. We understand you're making a representation that radioactivity is everywhere, and you're exposed to it everywhere. I think the question that the group would like to know is at what level should they be concerned? We've worried about norm. We've heard that norm has been injected into the well or whatever. There's been treatment of norm or some handling of norm on that property in the community. At what point and level should there be a concern from a medical standpoint that they may be exposed to some additional radiation that's not typical to the environment and may cause a concern? At what levels would you be concerned if it was in your neighborhood?
I eat salad oil. Obviously, my impression is that when I look at that, this is not my big area of knowledge. I just know a little bit. In fact, I'm a jack of all trades. I know a little bit of everything. And the specialist is the one that knows everything about nothing. I know nothing about everything. It's the two extremes. So don't count on me too much. If I look at that, I would say, salad oil.
But you didn't answer his question.
The question is, Doctor, I'm not trying to press you, but I think that's what it was. What would be alarming for you? I mean, not somebody dropping a case of salad oil in your house. Nobody's going to drop a truck full of salad oil. But, let's be referenced and relevant to the task at hand. And and if you're not the person to answer these questions, and we need some kind of
I'm not the person
radiation expert, but maybe we'll ask
you have to get a radiation expert.
Okay, so you're not a radiation expert?
Not at all.
Okay,
that's why
that's
it's
fine. Let's be more efficient.
In fact, I am an expert in nothing.
Well, I think you know what.
As you have seen.
No.
I'm just